After a giant asteroid caused the extinction of most non-avian dinosaurs, mammals had the opportunity to make the Earth their own. And they took advantage of this opportunity, quickly growing much larger than before. This tendency of becoming larger and larger continued for millions of years, until it reached its pinnacle about 34 million years ago when a titanic mammal emerged in Eurasia. It was considered the largest land mammal to ever exist, and since its existence, no land mammal has reached its size. But what was this giant land mammal? It came in the form of a hornless rhinoceros and was named Paraceratherium. It was significantly larger than any modern-day elephant, reaching heights of up to 26 feet or 8 meters at the shoulder and weighing around 40 tons. Paraceratherium had a long neck, a small head, and a large barrel-shaped body. It lacked horns or tusks, unlike many other rhinoceroses. It lived in Asia, particularly in what is now Pakistan, India, Nepal, and China. However, there is some debate around what really is the largest land animal, and there are some contenders to the title. In the 1800s, a discovery was made in India that unveiled a prehistoric elephant that was so giant that it shook up our understanding of mammals, and is today considered likely to have been even larger than Paraceratherium, making it the actual largest mammal to ever walk the earth. This was Palaeoloxodon namadicus. Identification names start with a genus and then followed by a species name. As this particular name suggests, this elephant wasn't a genus in itself, rather a species that belonged to a pre-existing genus, the Palaeoloxodon. This was a group of elephants that are believed to have first evolved in Africa some 4 million years ago during the early Pliocene, with the oldest species being Palaeoloxodon recci. The recci, like the namadicus, was a giant, with a completed male specimen indicating a weight of over 12 tons, making it larger than even any living species of elephant today. And each member of this genus would only get bigger and better, as between 600 to 800,000 years ago, a population of Palaeoloxodon recci migrated out of Africa and into Eurasia, where this migratory group would eventually become two new species. One was the Anticus, a monster elephant that tipped the scales at over 15 tons and was taller than nearly every theropod to ever exist. Ironically, many of this species would spread to islands throughout Europe, where its descendants would one day become the smallest known elephants of all time, a far cry from the enormity of the Anticus. Unbelievably, even this elephant was nothing compared to the second species that would arise from recci, Palaeoloxodon namadicus. The oldest specimen of this titan has been dated to over 700,000 years ago from the early Middle Pleistocene, and paleontologists were absolutely shocked by the sheer size of its fossils. They were especially fascinated by a femur that outsized that of a triceratops, and based on this bone alone, along with a right humerus, they estimated that this individual was 4.35 meters or 14.3 feet tall at the shoulders. Some years later, it was even more shocking when an even more giant femur was located, about 20% larger than the previous one. And this time around, paleontologists estimated the namadicus was in a league of its own, with this larger specimen being between 5.2 meters or 7.1 feet tall at the shoulder, making it taller than most giraffes while weighing 22 tons. At the size, it outclasses the Paraceratherium and takes the title of being the largest land mammal ever. Additionally, this absurd weight makes it heavier than not just the Spinosaurus, Giganotosaurus, or T-Rex, but also every non-sauropod dinosaur to ever live. It was even heavier than some sauropods themselves. This size was truly impressive, and it begged the question of how large terrestrial mammals could really get. But there is a problem. Many paleontologists are skeptical of this estimate as the remains found were quite fragmented, and many believe that 22 tons is a possible exaggeration of the specimen's true size. This issue of fragmentation, though, also extends to the Paraceratherium and other contenders of the largest land mammal title, leading to much debate and argument around this topic. However, not all is lost for the namadicus, as in early 2023, a study mentioned a more complete specimen known simply as CF Palaeoloxodon namadicus, and it was noted as being between 18 and 19 tons in weight. The study also included the Paraceratherium, which was given a weight of 17 tons, leading to an increased consensus that the namadicus truly is the current largest land mammal known to science. It should also be noted that at the specimen's weight, the namadicus still retains the achievement of being larger than the dinosaurs mentioned previously. And to put its giant size into more perspective, at its revised weight, it is still 300 times heavier than the average human and 3 times heavier than the average African bush elephant, the largest living land animal today. There can be outliers in every group, some smaller than average and some larger. That means that the namadicus possibly grew to sizes even larger than the maximum estimate of 22 tons. This is an idea that stems from modern-day elephants, which can show huge variety in size, as demonstrated by the largest recorded bush elephant, which was around 11 tons, about double that of the normal individual. Unfortunately, exceptional bulls like this one are 1 in thousands or even millions, meaning it's unlikely a behemoth namadicus will be found anytime soon. Along with the current specimens, their stature is nonetheless truly shocking, and the namadicus wasn't simply big, it was also quite robust in the way it was built, with its skull in particular being exceptionally sturdy. Along with being dense, the skull was also uniquely shaped, a common trait in Palaeoloxodon species, with a large crest located at the top of the skull that anchored the elephant's splenius muscles, which were used to support its giant head. This was crucial for maneuvering its skull and wielding its formidable weapons, its tusks. Like many elephants, the namadicus had 2 forward-facing tusks, which are believed to have mostly resembled those seen in the Antica species, which usually grew with a very slight curve or were practically straight. And like all other Palaeoloxodon species, it's also thought that the namadicus's tusks were proportionally long for its body, and considering it was a giant, it's generally believed to have had the longest tusks of any known animal. Namadicus's uniquely designed head enabled it to wield its massive tusks with ease. The stability of its skull allowed it to lower its head without losing balance, a crucial advantage for a grazer. The shape of its teeth suggests it fed on low-level grasses. Given that modern elephants consume 70,000 plus calories daily and spend 16 hours eating, it's reasonable to assume an adult namadicus required over 150,000 calories, which is enough to feed over 60 people. If it had to spend most of the day eating, that would have left the namadicus open to attacks from predators. However, thanks to its immense size and incredibly thick skin, full-grown adults would have been impervious to virtually all predators, which in its environment included felines, crocodilians, and wolves. Perhaps there was only one possible true threat to this giant: humans. Coexistence between humans and the namadicus has been confirmed multiple times, as certain formation sites have yielded both this elephant's bones and human ones. The question over namadicus' interaction with humans is less clear than other Palaeoloxodon species, namely the Anticus, Reki, and Naumani. These 3 species of Palaeoloxodon were all found with clear evidence of being hunted and butchered by both early humans and modern humans, suggesting that humans were quite adept at taking down extremely large megafauna. The Naumani in particular fascinated paleontologists as its direct descendants of a population of namadicus that successfully reached Japan via land bridge. These descendants were significantly smaller than their ancestor, being only half the size. Theoretically, an adult namadicus may have been exempt from human takedown attempts, although if the species was indeed targeted by humans, there isn't much reason that sick or juvenile individuals wouldn't be selected in the same way that wolves will do with pack animals. Many paleontologists believe that the namadicus was also quite intelligent, which could have proved useful when defending itself from any threats, including humans. The theoretical intelligence of the namadicus would have also played a big role in its social life, as it's currently believed that all Palaeoloxodon species lived in complex herds, which added another level of protection, especially for the smaller juveniles. This possible intelligence, along with its size and tusks, helped the namadicus become a truly successful creature, and fossil remains indicate that it was able to expand far and wide, with remains being found in multiple countries outside of India, including Malaysia, Myanmar, Laos, Vietnam, and southern China. Although some of these remains, especially the ones in China, have been touted by some paleontologists as actually belonging to yet another species of Palaeoloxodon. Unfortunately, as seen in many large animals, its size seems to not only be its main advantage, but also disadvantage. The namadicus is a relatively recent lost animal, with research giving it an extinction date of between 40 and 50,000 years ago. The consensus is that a cold trend in the climate led to a loss of its natural habitat of wooded areas, leading to a decrease in its main food items. And considering that this titan needed an extreme amount of calories to simply sustain itself, its population quickly declined after experiencing this habitat loss. Some paleontologists have also suggested that humans played a supporting role in its demise as well, citing that while there was a gap of 30,000 years between human arrival and its demise, there was a noticeable change in the population that corresponds nicely with the introduction of projectile weapons. Other large animals in its environment also became extinct around the same time, including the stegodon, a prehistoric hippo, and a zebra-like horse. Fortunately, unlike most extinct animals, we can still partially appreciate its glory today through its very close relative, the African bush elephant, and its even closer relative, the African forest elephant, which, interestingly enough, based upon a mitochondrial DNA analysis, was found to be closer in genetics to the Palaeoloxodon genus than to the African bush elephant, so almost like a cousin. And who knows, maybe this cousin may one day give way to yet another truly giant elephant that will be even larger thanks to evolution. If you enjoy learning about these benevolent behemoths, make sure to like, comment, and subscribe to Primalia for more exciting content. Share with a friend who loves ancient biology as much as we do. Stay curious.